yelling. Okay, so we're going to start with Oliver Pooley, Nomic Presentism, Relativity, and Rates of Change.
Okay, thank you. Thank you very much. Thank you to. Thank you very much to the organisers, Christian and Damiano. This looks like it's going to be a great event. Okay, so there's not much time. I'll press on. The title: Nomic Presentism, Relativity, and Rates of Change. Now, I should start by giving credit to Lakshand Mahanthris, who is a undergraduate student at Oxford, and a lot of what I'm going to talk about today came up in discussions with him as he was working on a thesis, and I got carried away with enthusiasm. Perhaps a bad idea, but anyway, this is what I committed to talking about. So here we go. This is the plan. I'm going to break it into 4 parts. I want to start by rehearsing what will be very familiar to lots of you, but perhaps stressing some things that don't always get stressed. The relativity objection to presentism. We'll then get on to nomic presentism, and this will be an occasion to talk about what the presentists should say about velocities and rates of change in general. And then we'll cycle back to relativity, and I won't have too much to say at this point, but it's really just showing how the things that we've covered will apply in the context of relativity. The sections get shorter as we go on, and I would like to say that's because I anticipated that I would be running out of time. Okay, the relativity objection. So here's a picture that's meant to put you in mind of the nice block universe representation of all of reality. So here we have a representation of all events that ever occur from no spatio-temporal point of view. And we're imagining that all of the space-time relations that hold between all these happenings and all the other structure, all the other relations, the natural relations are in there too. So how do we get from that tenseless description or conception of reality to the way that the presentist thinks about reality? So there's a very natural, straightforward way to go from that kind of conception of reality to the tense theoretic apparatus that is in the language of the presentist. So we need, and we don't need very much. So we've got this tenseless conception of reality, tenseless representation of reality, and all we need is a foliation of it, a slicing into things that are going to correspond to the instance. And we're imagining that the intrinsic structure of these slices are going to give us all of the untense truths that are going to hold at the relevant point in the tense theoretic model. And then the way I want to think about these tense theoretic models, we're going to have a preferred node in the model which corresponds to the present. And we read off what's true full stop for the present is from what's true at that node. And of course, just the ordering of these leaves of the foliation in the space-time model gives us the basic ordering relation in terms of which we get all the tense truths from the untense truths at every node. So if we've got a foliation, and if we can pick out which leaf of that foliation is the present, then it's easy to get from our block universe space-time picture to the presentist tense theoretic one. So why isn't it easy to do that according to relativity? So there are two problems that I want to stress. And the first is, suppose we know from experience, just from reflection and thinking, okay, here's my model, and in particular it's meant to represent how things are right now. That gives us the blue dot. But the blue dot by itself doesn't tell us which slice we should think of as corresponding to the present, because there's nothing in the relativistic picture of the world, given this blue dot, that tells us which slice containing the blue dot corresponds to the present. Suppose we go with the red one. Right, there's a further problem, not so much in special relativity, but in general relativity, which is if we look further to the future, just because we pick this slice, it doesn't follow that we should pick one or other of those two later ones. So here are slides saying these problems. Picking out the here and now is not enough to pick out the present slice. And I think it's worth contrasting that with the position in classical Galilean space-time structure, where there may not be a preferred frame of reference. There may not be a preferred way of, in addition to having the slices having what you might call a vibration, a set of preferred trajectories giving you same place over time. But nonetheless, if you identify where you are in space-time, it doesn't matter whether, what your state of motion is with respect to that slice. You know which slice is the now, if you know where you are in space-time, if the structure's classical. Now, suppose you say, well, actually, my experience tells me a bit more, right? Suppose that your velocity, your space-time, your full velocity in space-time, together with where you are in space-time, allows you to pick out what it does pick out in special relativity, the orthogonal slice to that direction. The problem with that is that there will be other people on that slice who have a different direction. And so what picks out the true now for you isn't picking out the now for them. Someone's got to be wrong, right? Someone moving at close to the speed of light relative to you will be having exactly the same kind of experiences according to our Lorentz invariant physics. And the natural slice for them to pick out, if the red one is the one you pick out when you're here, is going to be the other one. So there's nothing in experience. Experience might tell us we're here, but it doesn't tell us which slice is the preferred one. Okay. Problem 2. Just as a point, a place in space-time doesn't pick out a unique slice on which it lies, so a slice doesn't pick out a unique admissible foliation in which it lies, at least in standard general relativity. So I may not say more about that now. We'll come back to that later. Okay, so they're the problems that relativity poses. But let's go back to the picture and let's suppose that we have got our preferred foliation, and we're extracting from it this sort of tense theoretic description of the world. Here are some things to note about it. So if I've got a slicing, and if I've got a preferred slice, I've got enough to extract a whole bunch of untense facts for each point in the model and a load of tense facts in the standard way. But there are some other things that you might say are facts in the space-time picture that I'm not going to get just from the slicing and just from the preferred present. And some of these you think you might want, but you can't get. And there are also others which you definitely don't want, but are there in the space-time picture. So let me just say a little bit more about what those two kinds of things are. So if I just have the temporal distances between the slices as given by the proper time in the orthogonal direction, I just have the slicing, and I've got the spatial distances on these slices. I've got lots of facts about the relative distances expressed tense theoretically about how things are moving. So at this time, a pair of particles might be 5 meters apart. At that later time, they might be 6 meters apart. But in order for the Newtonian physics, sorry, not the Newtonian, especially relativistic physics, but well, sorry, forget that. Let's think of this. Let's imagine that this is a Newtonian world for a second, right? In order for the Newtonian physics we know and love, we want additional facts at this time. So, for example, that the particular particle has an acceleration, not just the relative velocity facts. How we get those in this picture is by having some primitive cross-time relations that get used in dynamics. But this presentist doesn't seem to be able to have those. In the tense theoretic model, everything's in the instant, right? And the only kind of cross-time relation is just the before and after relation. So the way the presentist might try and get velocities or accelerations is by having, in addition to a whole bunch of particles here, some points of space that persist primitively over time, and then they can define absolute velocities, but that's giving them a bit too much. So this is a standard kind of objection that presentists, you want these cross-time relations, you can get something which does the job they do, but it gives you too much, namely absolute positions. Okay. So there is this extra structure which we haven't naturally carried over, some of which we might want when we go from the space-time picture to the tense theoretic facts. Another thing to stress is that if we ask, okay, so what are the facts now, right? It's not just to be read off from how things are intrinsically on the red slice. Of course it isn't, right? The whole space-time is involved in telling you what the facts are now. We want all the tense facts. But of course that leads to the whole reason why nomic presentism was introduced under that name. Namely, we want to be able to say, if you're a presentist, how are those tense facts to be understood? So at the risk of labouring the obvious, right, here's one thing, even if you're a tense realist, you might think, right, there are some untense facts here, there are also some tense facts here. What makes those tense facts true is some untense facts at all the other places, together with how those other times are temporally related to this one. Of course, the presentist isn't going to say that because they don't believe that there are those other times. So, how is the presentist going to understand those tense facts? So, there are some standard examples that get described about these tense facts. So, for example, that there were dinosaurs, that seems to be a truth we want to recover, but for the tenseless block universe theorists, that's made true by the tenseless fact that there are these dinosaurs in the past. The presentist doesn't think there are those. So what is the presentist story about what makes there were dinosaurs true? I think this example is potentially not as helpful in posing the problem as it could be, because, and this isn't something I think I'm going to end up talking about, one challenge to the way the presentist wants to deal with some of these is whether they meet what you might call the aboutness criterion, whether their story about what makes the tense truths true is about the right kind of thing. And when we look at the sentence there were dinosaurs, I think it's not that difficult to say, well, that's about how things are now. It's a fact about the world that there were these things. It's not obviously about dinosaurs. It's just a claim that there once were dinosaurs. But if we consider some sentences which aren't explicitly past or future existential claims, for example, that the sauropods were the longest and heaviest dinosaurs, that does look on its face to be a claim about the dinosaurs, and in particular about the sauropods and how they compare to the rest of the dinosaurs. And similarly, the claim that the first Martian outposts will not be self-sustaining. That looks like it's a claim about the first Martian outposts, not about some future-directed fact about the current state of the world. Okay, so we need a story if we're a presentist and we don't think there are Martian outposts or dinosaurs about what makes these true. So here's one view. I'm going to put this down. If I'm going to carry on, can you still hear me if I don't have a microphone? Good. It's starting to feel like holding it like that. Here's what the exact presentist says about the truth of these past and future tense claims. So they say that we can think of times as maximally consistent sets of untense propositions. So we have our language that effectively is describing these three-dimensional slices in space-time. Says, particles are standing in these sorts of positions, that kind of thing. And we think of a maximally consistent set of claims in that language. And that's a way the world could be in untensed respects at a time. Amongst these, one of them is special, namely the set of untense propositions that are all true, the one that describes how things are in an untense sense right now. That's the present ersatz time. Now, what these guys do is add to this collection of abstract objects, these maximally consistent sets of untense propositions, a primitive relation called the E relation, E for earlier. This is just a sort of gadget, a metaphysical gadget that these abstract things stand into. And then you say things like, it was the case that there were dinosaurs is true because there is a maximally consistent set of untense propositions, which amongst it includes there are dinosaurs. And that ersatz time stands in the E relation to the time that is in fact true now. So that is what it is for the past tense claim to be true. And my reaction to this is that intuitively this gets the explanatory arrow back to front. Right? We think that this maximally consistent set of untense propositions that is true of this past time intuitively, it stands in the E relation to the present precisely because there were dinosaurs. We don't explain why it's true that there were dinosaurs in terms of this E relation, this primitive metaphysical gadget holding between these maximally consistent sets of sentences. So here's one of the defenders of this view, Craig Bourne, sort of addressing this worry. He poses the question, why is it that a certain atomic proposition P appears in a given E-related time, if not because it was the case that P? And then this becomes to him the question, well, to ask why these ordered triples are actually E-related, so the particular triples that are in his truth conditions that it was the case that P, is about as fair as asking why the concrete facts are actually earlier than related in the tenseless theory. It's not fair at all. All theorists take it as a brute fact that it was the case that P, and the advantage that he thinks both the tenseless view and this ersatz presentism have over the priorium presentist, which just takes these tense claims, it was the case that P, as a rock bottom, is that they have some story about what these facts, it was the case that P, looked like. Now, I think this isn't getting to the heart of it. So the problem is that the account of so we've got this claim about the E relation standing between these abstract times, and this is meant to be an account of what it is for it was the case for P to be true. But that's just not addressing the idea that no, it seems it's the other way around. It's the fact that it was the case that P is what explains why the E relation holds as it does, and that exactly doesn't seem to be true in the tenseless case, right? So in the tenseless case, it does seem to be good to say that there are tenselessly these dinosaurs, this particular temporal distance from the time at which I'm making this utterance, right? That explains why my utterance, there were dinosaurs, is true now. I slipped from talking about facts to utterances, but that's, I think, something that the tensor theorist is allowed to do and should do. I think another good thing to think about is the spatial analogy, right? So it's not a brute fact that that building is kind of over there, right? The brute fact is that a spatially unperspectival fact that this particular building, this location that I'm actually in brackets, is a certain distance from that building, right? That is the spatially perspectiveless fact that explains why it's true from here that that building's over there. Okay, so that's presentism. Not be favoured. Let's consider this alternative nomic presentism. So this is a view put forward by Marcosian, also discussed by Ted Sider, and recently defended in a couple of papers by Wheelers and co-authors in this particular case. So here's their phrasing of the view. Nomic presentism. For any tense fact P is true if and only if, and crucially, and because P is nomologically necessary given the present state of the universe. So an immediate comment on this proposal. I actually, when we're talking about future tense truths, find this because claim, right, that these future tense truths are what they are because of the present laws, not implausible, right, except that I'm a B theorist. But it's crucial for this view that it holds sort of symmetrically in both directions, right? It's meant to be that there were dinosaurs is true because something about the present state of the world and the laws. So I just want to flag, there seems to be this, to the extent that there is some intuitive plausibility to this idea, you've got to keep in mind that it's meant to apply in the past as well as the future. I think there are oddities about how truth makers change over time on this view, but it's not clear that this is a decisive objection. It's just how things should be if you really took this view seriously. So the kind of thing I have in mind is that, I'm currently standing, right? That's made true by how I am right now. I will be standing in a few minutes' time, right? That's made true by a whole complicated array of things that are true right now and not nomological, including that I'm standing right now, together with the laws. But as time passes, right, we get to the time when I'm still standing, and now the truth maker of the present tense proposition then that I'm standing is just that I'm standing. Now, of course, it wasn't the case that that proposition was made true by something else earlier. A different proposition, right? The future tense proposition that I will be standing was made true by how I was then together with the laws. But still, that future tense proposition considered at the earlier time and the later tense, the later present tense proposition, they're clearly, if you're a tenseless person, you think those sentences are expressing the same tenseless proposition. There's sort of a clear connection between them, and it's odd that their truth makers are so radically different. The third point is just a kind of answer to the first point. So, okay, you might think that there's this natural plausibility to the view when you consider the future direction, but not when you consider the past. But is that because you're mixing up causal versus metaphysical determination? I just put that on the table. Okay. So that's the view. Let's consider Marcosian, the main defender of this view. So the propositions he's considering are things like, a minute ago, the moon was more than a mile away from the Earth. In a minute's time, the moon is going to be more than a mile from the Earth. And he said of these propositions, it's very plausible that the truth makers for both of these propositions, so yes, past as well as future, include the Earth, the moon, their current arrangement, so for example, where the moon is, where the Earth is, and the laws, Newtonian gravitation, and so on. So note, the laws are listed there not as a condition on why the others determine the truth of these propositions, but as one of the truth makers. And also, well, that's it. Okay, so here's the first worry about the position as it's given when he talks about the current arrangement. So that doesn't look, it's obviously not going to be sufficient if by arrangement you mean things like, if we're working in the context of a Newtonian theory of gravitation, just where the particles are, how massive they are, how far apart from each other they are, that kind of thing, right? The position and the laws don't fix the history. If the laws are like the laws of Newtonian gravitation, we need the velocities. So, the arrangement might give us this point. The laws tell us which curves are physically possible, but there are two physically possible curves in configuration space passing through that point. So to pick out the actual history, we need not just a point, but a velocity at that point. Actually, so that's another thing to stress. So it's not enough to have a direction. Going to be physically possible curves in this theory that agree with this one tangentially, but have a different sequence of involve a different sequence of configurations. So we need to have the q dot, but of course the q dot isn't an untensed fact about the world. There's a quick and easy fix, of course. You'll just add velocities as intrinsic states of the world into our description of the untensed state of affairs. There will be more to say about this. Okay, so that's just stressing on the non-law ingredients in the truth maker. What about the laws themselves? So here is what Ted Sider said, considering lots of very similar things to things I've been talking about. He says of the nomological presentist proposal, understood as a response to this truth maker objection, unless we cheat the truth maker principle, or the principle that truth supervenes on being requires truth to supervene on, or be made true by fact, or be made true by facts about which non-tensed properties and relations are instantiated by which objects. And a law of dynamics must then hold in virtue of these facts. So amongst the truth makers is the laws, and Sider seems to be saying the law, that it's a law, must itself hold in virtue of untensed things. And Marcosian seems to sign up to this very same thing. So in this more recent paper of his, he says, here's a crucial assumption, right? He holds his hands up and say, I'm committed to the totality of present tense facts, which is what I've been calling untensed facts at any given time, being sufficient to determine a unique set of laws of nature that govern the world. So, you know, he's imagining I can throw in some extra metaphysical gadgets like perhaps Gretzky, Pooley, Armstrong necessitation relations. But if the things that these extra gadgets hold between are all untensed categorical properties and which objects hold them, it's not clear that we're going to get things that are recognizable as the laws, right? It just doesn't look like it can be done. We can't derive tensed claims from untensed claims. And if we look specifically at the sort of Newtonian example that we had in the back of the mind all along, we've thrown in velocities into primitive things. So amongst the laws, we've got things like V, this intrinsic property, it's going to be equal to Q dot, understood as claims about or claims constraining how the positions are at times other than the present. And you know, now we've thrown in V, we also need a V dot law. Otherwise, this is going to give us a future evolution. So we've now got these, you know, Q dots and V dots appearing in the natural way of expressing the laws, and we, if we're a presentist, need to say how we should understand those. Okay, so before I now talk a bit more about velocities and things like Q dot and V dot, one last comment about understanding these sorts of laws. So I think it's very natural to think of this guy as something like causal power, if you're thinking of it as an intrinsic property, things that exist in the instant, right? Its power is to make it the case that the future position of some object will be something depending on what its current position is. So I think V as an intrinsic velocity is naturally thought as a kind of causal power. You might think that this equation is merely nomological, but metaphysics, you know, it's expressing something of the essence of V. And you can make similar moves concerning V dot. So in this equation, we've just got that mass times inertial mass times V dot equals the we should have a minus here, gradient of the potential. And you know, we've got choice points. What are we going to throw into the instant? Do we throw in the potential? Do we throw in the force field? Then, you know, perhaps if it's a force, then it's part of the essence of the force to affect V dot or to be equal to V dot. or maybe, but then if we do that, we've got this connection between the forces and the gravitational masses, understood as gravitational charges, and the distance between the bodies. And is that now a kind of merely nomological connection between this thing that is metaphysically connected, the v dot, and these categorical things? Or do we think of gravitational mass as essentially a disposition to change v dot in certain configurations? So I'm just pointing out that there are these various choice points you have about how to think about these metaphysical things that you're going to need for the laws. 5 minutes. Okay, so velocities. So we've seen that in the natural expression of the laws, we've got these derivatives of quantities occurring. So how should we think about these? Well, as a kind of little warm-up exercise, I think this is quite a nice example to consider. So Conway's game of life, I'm sure, is familiar to many of you, but what you have is a very simple set of rules that determines which cells are going to be occupied. So think of the black cells as the occupied cells, which cells are going to be occupied at a next time, given the pattern of occupation at the earlier time. So in this rule, so think about what's being said about the middle cell in all of these. So if a cell that's occupied has fewer than 2 neighbours occupied, it will cease to be occupied at the next step. Here, because it has 2 neighbours, it remains occupied at the next step. And the same will be true of 3 neighbours. If you've got an unoccupied cell, which has 3 or 4 neighbours, sorry, that's the wrong thing to say. Okay, if you have more than 3 neighbours occupied, then you die, right? The cell becomes unoccupied. So we go from occupied to unoccupied. And here's the case where we've got 3 neighbours, and that gives rise to a new occupation, right? So it's completely deterministic. And we can think of, these occupying properties as kind of dispositions to bring about or destroy in collaboration with the neighbours, whether or not the cell's going to be occupied. Right? So you can think of them in this dispositional way. One thing to stress about this, in relation to what Marcosian wants to say about the past, is that although this is a completely deterministic system and the rules are very simple, the present state doesn't determine the past. Right? Imagine the present state, that no cells are occupied. Right? You've no idea, whether there were no occupied cells at the time before, whether there were just lots of them all over the place, scattered, so that they all died. So yeah, there's not backwards determinism, there's forwards determinism. According to Marcosian, that means you should think that the past is open. But if this is the law of the world, you might think, surely no, current state was brought about by previous state. Anyway, let's now consider the real life case, the Newtonian case. So we've got something like this. We've got the laws and some propositions saying that a particle has a particular position, and some propositions saying it's got a particular velocity. And we kind of want to say that entails that at the next time, in the next moment, then the position is going to be something or other. But of course, there is no next time, frankly. Time is continuous in the theories we're considering. So how do we think of these Q dots, right? We can't think of the content of the law in this sort of way. How do we do it? So there are fairly straightforward but very clunky ways of writing in kind of tense theoretic language things that correspond to the standard definitions of rates of change and velocities if you've got metric tense operators. So you can use them to give you a time index sequence. So just consider positioning. Consider doing it in terms of absolute position. You can consider a whole bunch of positions that the object has. So you're basically going from, for each real number n, you've got some claim x px equals xn. Right, so the position of the particle is xn, and so you've got all of these guys, and you can just take the limit and define velocity in a normal way. But you need this sort of continuum of metric tensor operators to define it in a normal kind of way. So now, if you say, okay, well, if that's how I'm understanding this, what kind of law is this? It looks horribly complicated. But of course, you might say, it already was horribly complicated. Velocities defined as limits are messy. There's one other thing to say, which is an initial attractive idea about intrinsic velocity is that we want something in the intrinsic state of the moment, which together with the laws accounts for how things are a moment later. But what we've just seen is that it doesn't work in this nice, simple way. There's no time in the future such that at that time the particle's position is due to the velocity and the position of that particle in the earlier time, which is to say, given the position and the velocity of the particle now, but any time later, the position of that particle be anything you like. What you need are the laws. What you need is not just this law, but this law too, right? And so immediately you need to know how these changed as well. So for any finite time forward, there's just not an obvious story, as far as I can see, that you can tell about how things are at one time, determine how things are at the next time. But I'm not saying that's a problem for the presentists. That just seems to be a problem for this kind of causal understanding of velocities. Okay, let me skip over what I was going to say about special relativity and say something about general relativity. So take a generally relativistic space-time. It's got its four-dimensional metric structure. We can consider a slice through it. On that slice, we have a three-metric structure, which is what this Gij is in these equations. And we also have something called the extrinsic curvature, which basically is the velocity of the metric with respect to proper time in the normal direction at that point, when you're thinking about it in space-time terms, right? That is closely related to this pi ij guy, the momentum in this Hamiltonian formulation. So we've got something which is like a metric velocity, and we can just treat it like an intrinsic property of the instance. So we've got the Gij's and the pi ij's. They're not understood, defined in to be defined in terms of velocities. And then we've got these two sets of equations which look rather like what we had way back here. Right, this is just a complicated version of something like this. But as I said, there's no preferred slicing, and this shows up in these equations because I've got these things n and crucially nij, the lapse and the shift, and there's no law for these, right? The velocity of these guys at any time is just a complete free variable. So the theory is radically indeterministic. Now, here's a natural thought you might say. Well, what these mean in space-time terms, this is just the ratio of the coordinate time rate of change with respect to the proper time rate of change. So I could set my coordinate time I could choose my time coordinate to be the proper time, and then this guy is just 1. This guy, the shift vector, is just, if I consider, 2 surfaces, and I go up with the normal, and then I consider same spatial coordinate here and here, the n vector, right? That's what the n guy is. So I choose my coordinates on this surface so that actually it's this guy. I can set these guys to 0. And if I'm a presentist, I just think of this being literally at the same place as this. And I think of, which surface should I go to next? Well, I go in these preferred directions by an equal amount of proper time. And, I get rid of these ends, and I've now got a deterministic way of thinking about these equations. And I interpret them in the way I've suggested you do. The problem with this is that it just breaks down, right? So in general, for an arbitrary hypersurface, 2 such normals are going to meet, right? This prescription of a preferred coordinate system is not going to work for any hypersurface in an arbitrary space-time. There are other things you can do. Move to what is called shape dynamics.
But that's not a good idea.
Well, shape dynamics gives you a preferred foliation. It reconceptualizes what the untensed properties are. You can interpret them in the kind of way I've been suggesting. So you think of the velocity as intrinsic to it. And there are some interesting details about whether or not you think that there is a preferred, whether or not you have metric tense space. If you do this, I'm happy to say more in Q&A about that. Okay, so not saying I've justified these conclusions, but here are the. I'll just read this up. These are sort of things I would like you to think about based on what I just run through. I won't read them out. Thanks.
You're gonna have to commit to being loud or use the mic.
Doesn't work.
It's not working.
Doesn't work. You turn it off.
It's working.
Just speaking very quietly, even with the
I'm being really loud.
Rolling, rolling.
You can go there wrong. You can go another microphone.
Can you hear me right now? Like,
I bet they can't.
Okay, all right. Like this. All right. Okay.
Hold up.
Great.
That's good.
Okay, so Allison, and then that's Tim over there, and then this gentleman, and then that person right there. Let's start with that. Okay, Allison, go.
This is just clarificatory. It seemed like in section 3, there was some kind of general problem about thinking of determinism in a kind of causal way, regardless of the concerns about presentism. I'm just not sure I got that. So was the concern that thought of in a causal way, I can't have the laws of nature as part of a causal understanding of determinism? Yeah, just what was that problem there? That was
So the laws are deterministic and strictly deterministic. So given the laws and given what is intrinsic to the instant when you put in the velocities, that fixes the whole history. There's just a puzzle about how you think it does it. So when you go to this sort of discrete time case, you think, the state of the the game of life at an instant, given the laws, fixes the future. But it does it by first fixing the next. That the way it works, the way it fixes the future is this state by the laws fixes the next one, and then the next one, and then the next one. And okay, I can tell you, given the pointing configuration space or pointed phase space and the laws, I've got a unique curve. But you want to understand that, sort of this determines the next bit, determines the next bit. And when the laws involve rates of change, you can't tell that sort of simple step-by-step story.
to clarify, if it's to be understood causally, it has to go step by step. It can't be some sort of general kind of constraint on how things go.
Yeah, well, so I want to say something weaker than that. There's a very simple-minded causal story you can say when it's not continuous. Sorry, when it's discrete. and you can't tell that story. And so I'm just puzzled about what you should say.
Yeah, so this is like a tiny little rant and a tiny little advertisement. It'll be very short. The presentist, I mean, the scheme here is you have the presentist and you say, well, how can they do physics? Well, let's look at Newtonian mechanics, right? Try and reproduce Newtonian mechanics, which is what this is mostly about. But of course, Newtonian mechanics, A, is wrong, and B, it's not even all classical physics. You look at Maxwellian electrodynamics, and there are two chief differences. Newtonian mechanics is a particle theory in its second order in time. Electromagnetics is a field theory in its first order in time. You don't have to put any velocities in anywhere. Fundamentally dynamic. And you also don't even have well-defined trajectories because it's a field theory, because you have particle trajectories, you can take their tangents. So this is just a comment that I think this focus on Newtonian mechanics, which leads to all kinds of problems everywhere, is just a very bad error, or at least could be. And then if you look at other kinds of theories to begin with, namely first order field theories, you're going to have a very different set of issues. And some of the things will go away.
So you said that was that just the rant?
That's it. That's
everything.
I mean, you can respond as to why, if you think looking at Newtonian mechanics.
So I think the move from saying the initial state is Q and Q dot to the initial state is Q and V, or maybe it's P and Q. That was the easy move. And then you have these thoughts, okay, well, I've got P and Q and it's all first order now. But I still have.
The point is, Q looks already like a velocity. If you're doing Maxwellian electrodynamics, you have E and B. Period. Neither of those is a velocity.
So the thought is that when the presentist says V, I'm saying is it metaphysically the case that V equals Q dot. But when you go to the Hamiltonian formalism and doing things in terms of P and Q, P is obviously a velocity. You've got these laws saying that P dot equals this thing, Q dot equals that thing. That's first order. And you've got the same in electromagnetism. You've got an equation for E dot and an equation for B dot.
Yeah, but it's because P is generally MV and V is itself ddt of Q, that when you do the Hamiltonian formalism of Newtonian mechanics, it's taking a second order theory and artificially making it look first order. Whereas electrodynamics is a first order theory. Anyway, if you have a reason for thinking Newtonian mechanics is a good idea, then maybe you could give me that. I'm just giving you reason to think it's a bad idea.
So yeah, my response is that not too much hung on that. So the puzzles were still there when we moved to the okay. I'm not sure I disagree with you in saying once I've got this V, then it's artificially first order when I've written it like that. But I wasn't worried by that. I was just worried by I've still got these first order, these rates of change in my equations that I need to understand as a presentist.
Not as initial data.
No, not as initial data in the laws.
Yeah, really good talk. What I was wondering is, so you have this nomic theory of presence, where it's already the case that basically the universe begets things. So something could in theory happen, but then all the information is destroyed, or it's determined the universe, whatever, and you could end up in a position where it's not nomically necessary, given the present state that thing happened in the past. So in some sense, you've got a kind of begettable universe going on. My question is then, why can't the universe just be forgetful about foliation? Like, why do you need the entire of space-time to be foliated when all you believe is the present? Couldn't it be the case that you just have a present, and as the present evolves, there is no fact of matter about which past events were co-present with one another? That information is essentially just forgotten. It's not determined by the present state.
So I think this sort of presentist should say the same thing about the past and the future. So when you were saying as the present evolves, were you thinking that there's a unique prescription about, I can't help myself, what happens at the next step? Or do you want to say that, there's just it's indeterminate, whether when you've got this lack of a preferred foliation, even given an initial data slice, one way of thinking about what's going on is it's indeterministic. There's going to be some fact of the matter. It's just the laws don't pick it out. But you might say, well, I can understand there being evolution, but there's not even a fact of the matter about what that evolution is. So I don't think you can just forget the past but then cling to this idea of determinate evolution to the future.
Yeah, it would need to be both, I think. It's just indeterminate as to what any future past slice would be. But it feels like if you're quite happy to do that with all sorts of other facts of the past and future, then it doesn't seem necessary to seek out a whole determinate obligation. That could just be determinate.
Yeah, hi, thank you. This is a plug rather than a rant. A lot of what you say has already been discussed in the technical and philosophical literature in tensor modal logic. So let me just mention 3 points of contact. So, for example, one area of discussion is whether possibly P is the case, because there's some possible worlds in which P is the case. Some people go one way, some people go the other way. So that's an issue that relates to something you said about the corresponding tensor logic case. That's an issue that's been very much discussed. Now, it's well known that standard modal logic and tensor logics are expressively impoverished. So it's a question of how then we can express all the things we would like to be able to say. Now, you just followed David Lewis in thinking in terms of ersatz times. That's not the way the modalists do it. They actually enrich language with propositional quantifiers, that is, quantifiers that occupy an intentional position. With those quantifiers, you can then actually say, or except if you want to say, in the possible worlds framework. And in fact, the problem of grounding then looks very different. Anyway, I just want to say that if you think of it in those terms, not in terms of constructing these sets, but just in terms of quantifying about how things are, you need to have a very different view. And it's from a technical point of view, it's a much more satisfactory framework. And the third thing I wanted to say was actually had to do with you introducing these metric tensor operators. So there's actually this work of Hans Kamp in the late 60s, where he showed, I think it was with continuous time actually, that if you added these two operators, since and until, to the language, you could say everything that you could say in the corresponding first order language. And of course, if you added then propositional quantifiers as well to the language, you could then say everything you want to say in the second order language, and so talk about limits and what have you. So there are probably alternatives to this ugly way of using these metric tensor operators to saying, for the presentist, to be saying what they want to be able to say. Anyway, I just wanted to mention that there are these various points of contact, this other literature.
So I take it that introducing since and until and introducing propositional quantifiers will give you the resources to, maybe a relatively tidy way of talking about limits and talking about these.
Yeah, you're not going to get a metric. Actually, that's something.
That's right.
One thing you're not
Exactly.
going to get. Yeah,
That's what I was going to say.
yeah. That's true.
Okay, so we're a little short on time. Can you just pass the two persons to the right? And there we go.
Thank you. I want to ask, so there seems to be the problem with the fact of how we think about velocities. The standard way in terms of limits, which require us of different moments. But what if we think in terms of non-standard analysis, decimals, where all of these would be in the present? So could that be a way to go about it? Think of the present as not as being
Oh, I see.
one instant, but it's
Right, it's temporally extended by the infinitesimal. So. Okay. Yeah, so what I haven't thought about that properly. I mean, my initial reaction was that it didn't help because you're still dealing with, you're not getting a next time. You're still sort of having to quantify. But yeah, of course, if you're putting them into, if you're putting all the infinitesimals into the present, that does. I mean,
And you can define velocity.
yeah, that's interesting. I need to think about that more. Thank you.
Thanks. So this is the sense of follow-up. Can you repeat the argument why I cannot take velocities in coordinates?
So sorry, I didn't hear the question. Why I can't take.
The rest of this one could be why can't I take velocity? So that's the thing.
So you can, but if you do, in order for them to do the work, you still need to connect them to the non-primitive notion of velocity.
Why is this for?
Why is it?
For the present?
So for the nomic presentist who claims that the laws are what they are in virtue of some untense things, it looks like that's an impossible breed because the laws state that these primitive velocities are related to these non-primitive velocities, and those non-primitive velocities are understood in deeply tense theoretic terms, however nicely you manage to do it. So that's fine. If you're a primitive, if you give up on the idea that somehow you're going to get tense from no tense, then that's fine. So now you've just got your tense theoretic way of understanding rates of change, which, there might be neat ways to do it. And now there's just this puzzle. Part of what's motivating your presentism, presumably, is this idea that, that it often goes hand in hand with, how things are at the instant. It's causally responsible for what immediately follows. And if the laws take this rates of change form, then, more needs to be. I'm saying I haven't seen the nice causal story about how that's meant to go.
Okay, maybe we can discuss this later. Oh, do I have 1 minute? No. Okay.
That is being fun.
We can do one more very quick one, if anybody has.
Oh, okay.
Yeah, I guess it's I guess it's related to the infinitesimal. When you say that, well, we can make rates of change intrinsic, that sounds a bit weird. No, I mean they either are or are not. I mean we're not making them anything. So I was thinking to really make them intrinsic, you would have to change your conception of what they belong to, and make that these things bigger. So you would have a kind of extended present, but then presumably the picture would be quite different.
So I think if the present had any finite temporal duration, first of all, I don't understand how that's meant to work in terms of presentist speciphysics. But then also any duration you gave it from this point of view would be arbitrary because you could always go smaller. I guess what's interesting about the infinitesimal living in the present idea is that you have a more principled way of delimiting what goes into the present.
Okay, let's take our speaker.